right, you've made it to Chapter 9, Mechanical Equipment. There is a lot of stuff we're going to talk about in this chapter. We've incorporated a lot of equations to hopefully make your guys' lives easier, make your construction documents more accurate and dynamic as your design changes, and also to reduce errors. So the first item we're talking about is editing airflow and schedules. So why is this even a topic? Well, in the world of calculations, you have values in schedules that end up not being able to be edited. So really this comes from the ability to use a connected airflow stream as your airflow or to override it. If you want that functionality, then everything we've done for you, that we've done in the MPP, is for you and for me. If you don't want that, if you want to just be able to edit your airflow on the fly in your schedule, then I'm sorry, it's not set up that way. However, it can work in both cases. So for the case of an ERV, I have our energy recovery unit summary schedule here. We have some airflows. So, as we were talking about, if we're going to have formulas and equations with the ability to use the connected airflow or override it, these values now are not editable. So you have a couple options to edit this. The first is to unhide the overrides. So you could come into here, and we can go to formatting, and I know what the parameters are called very easily. However, it may be a little more difficult to find these for some of the users till you get familiar with everything. So our inputs are our overrides, which we've been talking about since the beginning of this mechanical productivity pack. So there we go. Now we can edit this input value to be whatever we want. We could say this ERV needs 3000 CFM. So you'd end up hiding this column when you're done, and then you go from there. So that's option one, which isn't really great. So let's hide this column again. So, and where these airflows come into place is these supply and exhaust airflows essentially tie into all the components within the given unit. So we put formulas in those components so that you don't have to edit things multiple times. For example, the primary and secondary fans, SF2 and EF2. We have our component schedule, primary and secondary fans here. So now that fan airflow is being driven by that supply airflow value. So you don't have to edit these in multiple places. It also allows us to use this airflow in coil calculations, which we'll be talking about more as well. So that's some of the components that it filters down into. Same with like the airside energy recovery. Those airflows are coming into the outside air primary airstream for summer design and for heating design. So there's our exhaust there. So now what's the best way to edit this? Well, essentially we've made a schedule for you guys to make that real plain and simple. We've added a sheet which we haven't really talked about in the user manual yet, but it's this quality control sheet. And we see this as a place where people can review the integrity of the model and all of the data. This is just one of the many places to do it. So we have our air terminal sizing schedules, we have our ASHRAE calculations, all the duct and pipe systems, we have verification of flows, which we'll be talking about later on. And then we have this equipment airflow verification. So first I'm going to start off with the connected airflow verification. So looking at this schedule here, what we see is the calculated airflow. So this is from the connector, and then the design is essentially what shows up in the schedule. These gray values are gray columns are formula-based values, with the exception of this calculated value, but we don't want to modify that. So if you needed to change a design value, you would go to your input for supply airflow. So for the case of ERV1, right now we have no connected airflow. So if we were going to use connected airflow, we'd be at 0 CFM. So that'd be a problem. So really, we're going to override the input here to be what our design is. And now on the return exhaust side, maybe the designer obviously spent his time and made all those connections for us. So now we don't have to use any input. Our scheduled value is now dynamic with the design. The reason this is also important is with air handling unit systems, if you're talking about peak or block airflow, the connector is going to show the peak or connected airflow. If you're designing off of a block airflow, then you need a way to override that. So that's what the inputs are there for. So all of the families function in this sense. There's a couple unique ones like fans, where we don't have a specific supply airflow connected, calculated, or return, because we're using the same connector for both. So in this situation, if you wanted to override a given calculated airflow, you would use this design airflow parameter. So if this fan is supposed to be 150 CFM for design, so now it doesn't matter what we're using for calculated airstreams, this is what will show up in the schedule. So taking it one step further now, I'll show you some of the components. So this schedule up here, equipment component airflow verification, it basically is the same schedule we just looked at, but now it's expanded upon for a handful of things. So for things like fan airflow now. So as I mentioned previously, fan airflow is a calculated value that comes from the supply airflow or design airflow in the case of the fan family. And then we have secondary fans, which comes from the exhaust airflow stream. And then we have our energy recovery devices, so all of these are calculated values. And this is more or less just a summary for people. So cooling coils, if you needed to override the supply airflow, same with heating coils. If you needed to override the supply airflow, you have that capability. So those are just summarizing the components. This is also a place where you could update outside air flow. So in this case, this is an energy recovery unit, so we have 100% outside air. However, like for the case of the rooftop unit family, these RTUs here, once again, we have calculated airflows, and I haven't applied any overrides yet, so now we're using those in our schedules until we want to override them. For outside airflow, some of the families work differently. You'll see that this outside air percentage is a calculated value here. So in this case, you would want to edit your outside airflow here. And also, if you wanted to get to, exactly 27% or whatever it ends up being, you can type in a formula here, equals 0. So say we want 30% times 6730, which is our design airflow. So you can type in formulas there to get to a precise percentage. But usually you're editing this airflow and the percentage is what it is. So that essentially is how you edit airflows in all of these mechanical equipment schedules that now have a lot of formulas in them.